Our next example involves a negative numerator and two non-integer numerators. We have already shown that if you have two fractions that have integer numerator and denominators, you can include negative or positive, it doesn't matter. You still add by adding the numerators and keeping the denominators the same. If you feel like that you do not need to see this example, feel free to skip it. Now you may have noticed this funny symbol here. What does that mean? It means square root. We are trying to find the positive number that if you multiply it to itself, you will get 11. Now there is a minus sign before the square root of 11 in this case. Negative square root of 11 is negative, but square root of 11 by itself is positive. In fact, that's part of the definition of square root. This is simple square root of a number is a positive number that if you multiply it to itself, you get the number inside the square root, which in this case is 11. But anyway, what is the square root of 11? Well, the square root of 11 is approximately 3.31662. If you take the negative of both sides, negative square root of 11 is approximately negative 3.31662. We do have one other non-integer numerator. It is this, 5 1/3. What is 5 1/3? It is a mixed fraction. Written as an improper fraction, it is equal to 16/3. 5 1/3 is approximately 5.333333333. So now let's get negative square root of 11 over 9. So we need about negative 3.31662 ninths. Negative 1 ninth. Negative 2 ninths. Negative 3 ninths. So we need a little bit more. Negative 4 ninths. Well, that was too much. We in fact need a part of this piece, of this ninth. We need about 0.31662 of this piece. So let's go and cut it. Let's now get positive 5 1/3 ninths. 1 ninth, 2 ninths, 3 ninths, 4 ninths, 5 ninths. We need a little bit more. 6 ninths. Well, that was too much. We only needed 1/3 of a ninth, and here is 1 ninth. We will therefore need to cut into this piece to get 1/3 of a ninth instead of 1 ninth. Well, let's go and do that. I would like to note that although these look about the same size, if you remove the negative sign, they are not exactly the same size if you remove the negative sign. This one represents negative 0.31662 and so on. This one represents 0.3333 and so on. So the difference is very small, like it's there in the hundredths place, but it's still there. Now let's figure out what negative square root of 11 over 9 plus 5 1/3 ninths is by combining these. Well, here is negative 1 ninth, here is positive 1 ninth. Combine them together, you get 0, because negative 1 ninth plus positive 1 ninth is equal to 0. We can continue doing so. And we are left with this. But we're not finished here, because some of the positive over here should cancel out the remaining negative we have. We should end up with all positive or all negative. But we can't just have these two pieces together and remove them from the scene because they don't add exactly to 0. Sure, it's very close, but not exact. So what I'm going to do is that I'm going to replace this with this. This piece would be the difference between the magnitudes of the two original parts of the circle, between the original red and the original green. And then this would be the positive part of the red part. And so if you add these together, you would get 0 because this one is negative 0.31662 ninths approximately, and this one is about positive 0.31662 ninths. So when you add them together, you'll get 0. You can remove them from the scene. Now I would like to note that that is not to scale. If it was to scale, I think it would be a lot smaller. However, this is just a model. And anyway, we are left with 2 and a little bit of a ninth, 2 and a little bit ninths. In fact, we are left with approximately 2.0167 ninths. If you want to talk about exactness, we have exactly negative square root of 11 plus 5 1/3 ninths. That is what we have exactly. Suppose that I wanted to solve this problem without the main denominator, without everything being in ninths. How would I do that? Well, first I would need to get negative square root of 11, and that would be approximately negative 3.31662. And here I have negative 1, negative 2, negative 3, and then approximately negative 3.31662. Then I would need to get positive 5 1/3, positive 1, positive 2, positive 3, positive 4, positive 5, positive 5 1/3. Then I would need to simplify this. So here I have negative 1, and here I have positive 1. If I add them together, I will get 0, so I can remove them from the scene. I can continue doing this until I am left with this. Now I'm not done yet because I still have negative and positive, and some of the positive can cancel out the remaining of the negative. I need to end up with all negative or all positive. But I can't just take these two and cancel each other out. Why? Because positive 1/3 is slightly bigger than negative 0.31662, and so on, if you forget about the minus sign. So what I'm going to do is that I'm going to exchange this for 2 pieces of this. Again, this piece is not to the correct size. This is just a model. Anyway, now I have negative 0.31662 approximately, and positive 0.31662, and so on. And if I add them together, I will get 0, so I can remove them. So what I'm left with is 2 and a little bit more. So therefore, negative square root of 11 plus positive 5 1/3 is approximately 2.0167. As you might have noticed, what we did in this example was a lot similar to the previous one where everything was in ninths. The only difference with that one is that everything was in ninths. So that shows to add those fractions in the previous example, you add the numerators but keep the denominators the same. The next video in this set of videos is part 6C, which is the third example when you include non-integer numerators. If you would not like to watch any more examples for this case, feel free to watch Part 7a, which is the first example for when you include non-integer denominators.